In this video tutorial, we continue with the design of the Gatekeeper's Lodge doors, drawing inspiration from the arts and crafts historical era of architecture. Today we're drafting a typical entry-style door with mortise and tenon joinery, but in this instance, since the door is meant to be an entry door, the material should be thicker and the tenon will go through the mortise of the style and secured with wedges. In previous videos, we drafted standard interior doors depicting an assembly of rails and stiles, utilizing mortise and tenon joinery, but the tenon did not go through the stile. This is okay for interior doors because they are lighter in weight. For example, a solid entry door could be 2¼ inches thick, whereas the interior doors are typically 1½ inches thick. A thicker entry door is a good idea because it provides more security, better acoustics, and can be more insulated. The strength of tenon through the mortise joinery adds construction stability as well. Let's now move on to draft the entry door. We've chosen a rail and stile construction with 8 lights or glass panels. To begin setup, copy a baseline reference to space the doors apart. Next, turn off the visibility of the A dimensions and A pat layers in the Layer Manager panel. Copy an interior door to the end of the reference line. Using the construction line command XL, add the guidelines to define the overall width and height of the door style. Begin with a horizontal construction line positioned at the base of the door. Use the offset command to create a reference line for the new door height, which is 95½ inches. Add a vertical construction line positioned on the left side of the outer stile of the door. Offset the vertical construction line 41¾ inches for the new door width. Use the stretch command and the green crossing box to increase the door's dimension one direction at a time. I will stretch the door horizontally to fit the construction guidelines. Be sure that the ortho F8 function key is toggled on. Using the stretch command with the green crossing box again, I will stretch the height of the door to fit the vertical guidelines. Always check your work as you progress through the drafting process so that you do not compound a previous error. Use the distance command to check that the overall dimensions are correct, and make sure that the OSNAP F3 function key is toggled on. Since the dimensions of the top panel and the intermediate rail will need to be modified, let's go ahead and erase the intermediate rail for now. We will begin the process of drafting the divided light panels just below the top rail of the door. Set the offset distance to 7 inches and offset the bottom line of the top rail down. Set the offset distance to 1 inch and offset the new line down. Again, set the offset distance back to 7 inches and offset the bottom line down. Finally, set the offset distance to 6 inches and offset the bottom line. This will represent the new intermediate rail. We have now created the vertical height of 2 rows of what will become the divided light panels, separated by a horizontal muntin, which helps to support and frame the rows of glass. Set the point style to 3, and use the divide command to create 4 equal sections of the top panel for the divided light. Make sure that the O-snap settings include nodes and perpendicular in addition to the typical object settings for precision drafting. Once you have drafted the vertical lines at each node, select and delete or erase the nodes. Use the trim command to trim the vertical lines between the horizontal muntin. Set the offset distance to 0.5 or 1/2 inch and offset the vertical line to each side. We are now creating the mullions that frame and support each panel of individual glass, thus earning the name divided light. During the arts and craft period, this was typically an amber or green-colored glass to provide some light but also privacy. Each panel might even have been made of bullseye glass. Now erase or delete the vertical reference line of each mullion. Trim each mullion where it meets the muntin to create the individual glass panels. Select all of the mullions and muntin with the green crossing box and organize the lines onto the I-elevation-medium light layer so that the line weight of the door detail will read with a good visual hierarchy when plotted. We are next going to get set up to draft the center stile of the door between the intermediate and bottom rails. This will create equal recessed panels on either side of the center stile. Start by drafting a vertical line at the midpoint of the intermediate rail to the perpendicular point of the top of the bottom rail. Offset this line a distance of 3 inches on each side. Delete or erase the center vertical line. Use the distance command to check the width of the right and left outer stiles, bottom rail, and center stile. Use the distance command to check the mounting height from the center line of the lock set to the baseline of the door. Turn on the visibility of the A-pat layer and make it the current layer. We are now ready to add hatch patterns to the door rails, stiles, and panels. Add hatch to only one type of door area at a time. I will start with the door rails and add any hatch pattern. In this way, I can then use the Match Properties command to match the pattern, scale, and orientation from a previous door detail. Remember, I am only going to match properties to another door's rails. I will repeat the hatch command by adding any hatch pattern to the door's vertical panels. Then use the Match Properties command to match the pattern scale and orientation from a previous door detail. By drafting this way, you will ensure consistency of materials for the whole door schedule. Again, use the hatch command by adding any hatch pattern to the door's outer stiles. Then use the Match Properties command to match the pattern scale and orientation from a previous door detail. The last area to hatch is the door's center stile. Repeat the hatch and Match Properties commands as we did on the other components. Make the I-elevation-fine layer the current layer to prepare to draft the symbols to indicate glass. It is important to indicate glass materials by drafting 2 parallel but unequal in length lines on an angle. You will need to turn off the ortho F8 function key to be able to draft diagonal lines. Copy the set of double lines to every other compartment of the divided glass panel. Make the A-dimensions layer the current layer and use the Shop ZZ dimension style to dimension the components of the entry door. Start with the linear dimension command for the overall width of the door. Utilize the linear dimension command again to dimension a typical glass panel. Use the continued dimension command to dimension the muntin and the bottom row of glass panels. Use the linear dimension command to dimension the top, intermediate, and bottom rails. Try to align the dimensions vertically so that they create an even stack of dimensions. You could always use a construction line if you wanted to be even more precise. If the APAT layer is visible, make sure that you zoom in close when dimensioning so that you pick on the correct part of the door assembly and not a portion of the hatch pattern by accident. Finally, dimension the width of the center stile and overall vertical height of the door. Since the vertical outer stiles are not unique to the construction of the other doors in the door schedule, you could leave those off undimensioned in this door assembly, but it might be wise to at least dimension the two recessed panels on either side of the door, although I am not demonstrating that here. It is now okay to delete or erase the construction guidelines if you haven't done this yet. Insert the joint details provided beneath the correct doors. Remember, the interior doors are thinner in construction and require standard mortise and tenon joinery, whereas the exterior door is thicker and we've opted for wedged mortise and tenon through the outer stile. An easy way to work on the D-size detail sheet that is our door schedule is to copy a viewport that is already scaled to the specific areas for the entry door and the joinery detail rectangles. Center each viewport above the respective title bar. Adjust each viewport rectangle so that it does not overlap the title bar. Toggle off the O-snap F3 key if the O-snap magnets snap back to the original position during the resizing process. Activate one viewport at a time and pan the correct detail drawing into the viewport rectangle. Deactivate the viewport and then grip the viewport rectangle and check that the architectural scale designated to the viewport matches the specified scale in the title bar. Do this for each of the new details. It is now time to plot the updated D-size sheet as a PDF file. Be sure to add a unique name to this plot, such as EXT for exterior. Now tab over to the A-size sheet. Set up the A-size sheet to be printed as a PDF file. Always preview the final plot or print to make sure that the viewports are correct and all the layers are turned on.